Question 1. I recommend you pause the video here just to re-familiarise yourself with the question, so I won't read it out. But in question 1, part 1 rather, you simply need to recognise that there are 3 different outcomes when you take the test the first time. That's accepted, rejected, and retested, with the probabilities 0.2, 0.5 and 0.3 respectively. Now if you are retested, then you simply get another go and there's no change, so we can draw the same thing again for the second kind of phase of the tree diagram. And then if you need a third go at it, then they remove the option for retesting, so you simply are either accepted or rejected with probabilities 0.4 and 0.6 respectively. So there's our complete solution to part 1. Now for part 2, you just need to pick some different routes through the tree diagram. Find the probability that the randomly selected candidate is accepted. Well, they're either accepted the first time they take the test, or they have to retest and are accepted the second time, or they're retested and then they're retested again and then they are accepted the third time. So we just need to add up those probabilities. So we've got 0.2 for immediate acceptance, or we're retested and then accepted, or we're retested and then we're retested again, so 0.3 times 0.3, and then we're accepted. And that gives us the answer. I haven't got my calculator with me, excuse me, I'll just have to look it up. Answer 0.296. Now for part 3 is fiddly because there's loads of information there and you've got to try and understand what it's asking, really. So let's try and make sense of it in as systematic a way as possible. We're finding the probability that a randomly selected candidate, so somebody entering this tree diagram, is retested at least once, given that this candidate is accepted. Now, when you're dealing with a given question with the word given in, you're almost certainly going to need to invoke the formula, which I'll put at the top of the page here, which is in the formula sheets, that probability of A given B is equal to the probability of A intersection B, A and B, divided by the probability of B. So what is our A and what is our B here? Let's define those so that we can make sense of it. Our A will be this bit here. The candidate is retested at least once. Okay, B then is the bit after the word given that this candidate is accepted. So I'm just going to write that B is candidate is accepted. Okay, well, we want to use our formula then here. We need the left-hand side, but we can obviously calculate that by investigating what the right-hand side means. So the numerator, probability of A intersection B, this is the probability that both of these things happen. So the candidate is retested at least once and they are accepted. Well, that means they must be here or here. Those are the only outcomes, the only sort of final positions on the tree diagram that satisfy A and B happening. So the probability of those two, or one of those two happening, will be the second 2 bits of my previous calculation added up. So 0.096, we can do that in our heads. So 0.096. Now probability of B is the probability they're accepted. Well, that is just the total answer. That's all 3 bits in part 2, which of course we know the answer to already. So we have 0.296. So the final answer then, probability of A given B, is 0.096 divided by 0.296, which gives us 0.324.